All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up 78 is on the screen. Number 1 says graph f of x equals 1 over x. Number 2, graph f of x equals x squared, then transform it according to g of x equals f of x minus 3 in parentheses plus 5 over 2. From there, we got number 3, rewrite each expression. Part A is a to the negative 4. Part B is 9 to the 0 exponent. Part C is 1 over y in parentheses, all that to the second power. Number 4, we got if x to the third times x to the fifth is x to the eighth, which means we add 3 and 5. Then rewrite 3 to the x plus negative 2 as the exponent. And number 5, graph the circle, x squared plus y squared minus 8x minus 4y plus 16 equals to 0. Copy that and go. All right. Let's go over numbers 3 and 4 really quick. Before I pick someone, share your answers with your neighbors, see what they got for numbers 3 and 4. 3 and 4 on the warm-up. All right, let's see. 3A, good conversations. A for Miguel. What'd you get, Miguel? Okay. Then help him out, Sky. 1 over 1, the reciprocal. So then this becomes 1 over a to the positive 4. And we got that? Okay. 3B. Everyone. 1. Yes, by now any number to the 0 exponent is 1. 3C. What'd you get for 3C? Raymond, what'd you get? Y squared. That is correct. How do you get there? Well, let's see. He distributed the negative 2 there, so this was 1 to the negative 2 over y to the negative 2. Then he did the reciprocal, so that gives us y to the positive 2 over 1 to the positive 2, which is y to the positive 2 over 1, because 1 times 1 is 1, and that's how we got y to the second. All right. So, with that said, if x to the third times x to the fifth gives us x to the eighth, but the step before that shows the process, which is x to the exponent of 3 plus 5. This is showing us the process. 3 to the x plus negative 2. What does it look like right before we got to that step? Tell your neighbor, what does it look like right there? Good conversations. All right. Let's see. Help us out, Andy. What do I write there? 3 to the x. To the negative 2. That is correct. Now, can we simplify that? Yes, Mr. Q. Can we leave this as a negative exponent? No, we do the reciprocal, so that gives us 3x times 1 over 3 to the second. Yes? Okay, so if we write this over 1 and we multiply, this is 3x times 1 is 3x. 1 times 3 to the second is 3 to the second. Can we simplify this? Yes, this is 3 to the x, move this up so that you guys see it's an exponent. 3 to the x over, what is 3 squared? 9. And I'm going to leave it like that for right now. All right. So, let's go to the graphing portion. Here's the graphing. All right. So before I pick either Sky or Miguel, tell your neighbor, show your neighbor that graph really quick. See if they have the same thing as you. All right. So this, once you did your table, it looks like this and like this. And of course we have this point and that point. So, Miguel, pass someone. Lenny, what is this point right here for that parent function? 1. 1, 1. Yes, that is correct. And this point right here is -1, -1. Yes, that is correct. And have you got that in your table? Yeah? Okay, good. Next, this one, the parent function goes through here and there. There it is. And then we needed to transform this, so this becomes, we put a 1 there, we get this fraction out of the way, so it's 1/2 f of x minus 3 squared plus 5, and all that equals to g of x. So, we know this goes to the right 3 steps and up 5 steps, yes? Okay. So, what does this do to the original parabola? Talk it over your neighbor before I call on Sky. Good conversations. All right, Sky, pass someone. Philip, what does that do to the original parabola? It compresses it, because now instead of being at 1, 1, which is that one, now it's going to be at 1, 1/2, because that's where we get that 1/2. 1, 1/2, which is right there. That's where the parabola compresses like so. So, if that's true, now all we have to do is what? Move it 3 steps to the right and 5 up. So I'm going to take this 3 steps to the right, 5 up. So those 2 points are right there. And there's my itty-bitty parabola. And there it is. Pretty straightforward, yeah? Yes, Mr. Q. And last but not least, our circle. Now, for the sake of time, you should have subtracted 16 from each side, yes? Rewrote that with that, x squared minus 8x, plus this with this, y squared minus 4y. Completed the square, yes? You wrote something here, divided by 2 squared, which was 16. So you do that to both sides. And here the same thing, and you add 4. Therefore, see what I did there? Therefore, square root, that is x, 4, sign of the middle, squared, square root, y, 2, sign of the middle, squared, these cancel, and we're left with 4. And if you got that by yourself. Okay, some of us, yeah? So, our center of this circle, the center is h and k, so the center is at 4, 2, from there. And the radius, we get it from taking the square root of 4, radius is 2. So if we plot our center is at 4, 2, 4, 2, and radius 2 steps in all directions, here, 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 and here, and there you go. Pretty good, yeah? Yes, Mr. Q. All right, good. All right, set that aside. Agenda for today. Here we go. Warm-up number 78. We're still on rational functions. Home plate pages 394, 395, but tonight we're going to do evens. Evens. Since you guys loved last night, so now we're going to evens. The master plan. So I was telling the other class that I was reflecting on this year. This year is going to be my 16th year without using a whiteboard or a chalkboard. Isn't that crazy? I mean, I use them for posters. You guys see the posters in the prints here? But other than that, I mean, it's been all digital. Bam, let's go. We got this, yes? For my techie people, you guys techie? Some? Yeah, all of you, yeah? Most of you, yes? All right. So, with that said, we're showing warm-up number 78, rational functions. Once again, tonight is 394, 305 evens only. So, no asynchronous code because we're still on the same session. And last night's home plate were the odds, so get that in front of you. Take a picture, submit on Canvas. Do that right now. Also get a Cornell note. You do need a Frere model. Get that up, please. And I'll give you some time to set that. Yeah. All right, here we go. I can solve and graph rational functions. I can solve and graph rational functions. In your Frere model, rational functions. Yes? Without looking at your notes, give me a definition in your own words as to what a rational function is. One example, one non-example, and one hashtag. Think about it. Rational functions, what are they in your own words? One example, one non-example, one hashtag without looking at your notes. All right. Give some time. But, all right. So, you should have something like this. You're like, oh yeah, I got it, Mr. Q. Okay, good. Well, in your own words, you should have written an equation with fractions, yes? Do these have fractions? Yes. Are they equations? Yes. One example, one non-example, and a hashtag. All right? So, I'll leave that for you to finish. You have notes, but you can finish that later on. So last night, you were to do the home play. You did three things. The first one, identify vertical and horizontal asymptote, build an input output table, and graph it. Yes? Did you get plenty of practice? Yes. Let's see numbers 1, 3, 5, 7, 9, and 11. That's plenty of practice, right? Okay, good. So tonight you're going to do the evens. However, where have we been? I gave you a general rule, then from there I applied it to the new rational function rule. And we said that the parameters do the same thing pretty much, except for H and K. They play a second role. We said that that second role was asymptotes. And what are they? Invisible lines that our graph cannot touch. And we started yesterday with vertical and horizontal. Next week we're going to get into what? Diagonal, slant, or oblique. Those are a little bit more challenging. So from there I said, okay, where have you been? So here we go. H is vertical. K is horizontal. Did we cover that yesterday? Yes. I gave you guys some practice. We did some of these to make sure we got it. But look at example mega Q. We said if we end up with something like this where the x has a coefficient, you needed to set it equal to 0 and identify the excluded value. That's our asymptote. Then from there I give you more practice, yes. From there we talked about the different functions that we've touched it. We've covered linear, quadratic, cubic, quartic, and then we got to the rational, and I said if we put a negative in front of it, what does it do to the entire function? It flips it. Yes? And last night you had some of those on your home plate. Hopefully you saw that. From there, we skipped this one because we did this one on the warm-up. We went straight to this one. Is that correct? All right, so today, for the sake of those of you that maybe you're superheroes or Power Rangers, you didn't do your home plate, let's do another one. Copy this one, please. Example 2 super Q. Y equals 1 over x plus 2 minus 3. We're going to go over the entire process once again. It's only 3 steps just to make sure we got this. Example 2 super Q reads, graph the function, identify the domain and range. We need to identify domain and range in order for us to graph it, by the way. All right, so here we go. First, what is the first thing we do? Identify the asymptote. So you need to write the very first thing. You write VAX equals HAY equals. All right. So by looking at it, this is supposed to be a negative, right? So that means it cannot be 2. So our VA is negative 2. Our HA is our constant, which is this one. That means it's negative 3. Now, for those of you that need refresher, here goes our general rule that we're using is A times F of 1 over B, X minus H plus K. Now, look at it. We have an X minus. This is not a minus. That's why that became a negative 2. And K is still there. That means our K is what? Negative 3. Okay. So that's our general rule. We don't need it. I'm just showing you to recap. So let's plot those on our coordinate plane. So make a coordinate plane over here on the side. And once again, this is exactly what you did for home plan. Just reiterating, getting us an extra practice. All right, here we go. X negative 2. Negative 1, negative 2. I'm going to do some more tallies. Negative 3, negative 4. All right. Y negative 3. We got 1, 2, 3, 4, 5. Negative 3 is right here, so I'm going to go through negative 3. There it is. All right. So, with that said, now that we have that down, we need to get a table going. X. And last night for your home play was G of X, but today is Y, just for the sake of that. Now, here it goes. Look up, please. This is where some of you missed a step. To get our domain, we need to first look at our asymptote, our vertical asymptote. What is the X value of the asymptote? It's at negative 2, yes? So our domain we need to choose 2 X values to the left and 2 X values to the right. So tell your neighbor what domain we're going to use, please. What domain are we going to use if we choose 2 to the left and 2 to the right of that? All right, we got it? All right, Brianna, what values? Negative 4, negative 3, negative 2, negative 1, and 0. Yes. Negative 4, negative 3. And Brianna thought about the negative 2. We need it there because we're going to label it what? Undefined. We can't use it, but it's part of the domain. Yes. And then negative 1 and 0. That's what you should have done last night to identify the domain. You first go to the vertical asymptote, pick 2 values for X to the left, 2 values for X to the right. Okay, so with that said, now all we have to do is take this and do some work to get some values. So let me zoom in. I'm going to rewrite that right here. We got 1 over parentheses plus 2 minus 3. Does everybody see that I rewrote this right here? Yes, Mr. Q. So what's my first value? Negative 4. So here it goes. 1 over, you got the negative 3. See, what is negative 4 plus 2? Negative 2. So now we have negative 3 and negative 1/2. So that gives us negative what? 3.5. Yes, that is correct. Let's do it again. Now for negative 3. So, next value is negative 3. What is negative 3 plus 2? Negative 1. So what is 1 over negative 1? Negative 1 minus 3, negative 4. That is like elementary stuff, yeah? Yes, I think you. All right, good. 1 over. All right, let's see. Next value is negative 1. What is negative 1 plus 2? 1. So what is 1 over 1? Minus 3, negative 2, yes. And last but not least, my next value is 0. What is 0 plus 2? 2. So we have a half and we have negative 3. So what is negative 3 plus 2? Negative 2.5. Yes, there it is. All right, let me zoom out so we can graph that. All right, there we go. Negative 4, negative 3.5. Negative 4, negative 3, 1, 2, 3.5, a little bit further down. There it is. Next, negative 3, negative 4. Negative 3, negative 1, 2, 3, 4. All right. So notice that after that is undefined, so that means the asymptote's next. So you connect these two from left to right, get them as close as you can to the asymptotes and curve it, and then arrows at the end. Arrows at the end. All right, next, go to the other side. We got negative 1, negative 2. Negative 1, negative 1, 2. And then 0, negative 2.5. 0, negative 1, 2.5, which is right there. Once again, from left to right, as close as you can to the asymptotes. There you go. Piece of cake, yes? So let me go over once again the 3 steps. Step 1, identify the vertical and horizontal asymptote. Do we know how to do that from the equation? Yes. We plot those. There you go. Step 2, get an input-output table. But the domain, we need to identify the domain first by looking at the asymptote, picking 2 x values to the left and 2 x values to the right. Substitute values, get your range, and there you go. All right. So now, so far so good. Now, write your utensils down, look up to the screen. Let me show you something really cool. Ready? Here it goes. And yes, it's mathematics, yes. So for the the warm-ups, look up please. I've been giving you for you to graph y equals, f of x equals 1 over x, which is the parent function of all these. What does it look like? Like this. F of x equals 1 over x. Haven't I been giving you plenty of practice for that? Yes. Okay. Which means if I was to graph this, like you did on the warm-up, it should look something like this and something like this. Is that correct? And of course that one has 0, 0, 1, 1, and negative 1, negative 1. Is that correct? Okay, now check this out. Right now I'm going to reveal what the asymptotes represent in regards to the parent function. If this is the original function and this has a transformation, now look, according to what we see, if this is h, that means we're going to move the function 2 steps to the left and 3 steps down. Let me repeat that again. 2 to the left and 3 down. Alright, so watch. I'm going to take my original function. I'm going to place it at the point of origin. There it is. You guys see it? I'm going to move it, what? 2 steps to the left and 3 steps down. So look at the point of origin. I'm going to move it 1, 2 to the left, How many down? 1, 2, 3. What do you guys notice? That the asymptotes is the actual coordinate plane, but now with the transformed function. Let me repeat that again. Here it goes. We start at 0, 0, and we move it according to the h and k, 2 steps to the left, 3 down, 1, 2, 3, and there you go. Now notice the green, this green dot, this one, I'm going to change it to red so you guys can see it. This is, the original is 1, 1. Is that correct? Didn't we say that? So according to this, I'm going to move it what? 2 to the left and 3 down. So watch. If I move this to the left, that means it was at 1, 1 right here. 2 to the left. 1, 2. How many down? 3. 1, 2. What? You guys see it? Some of you are like, I don't know, Mr. Q. I'm falling asleep right now because I stayed up late at night. All right. With that said, let's do one from the home plate. Ready? Copy this one. We're going to do number 11 together. Zoom in. Number 11. Even if you already did it, let's do it again just for extra practice. We got g of x equals negative 5. I'm sorry. G of x equals negative 0.5 times 1 over x minus 1, close parentheses, minus 2. All right. So, tell your neighbor the very first thing we should do. Very good. Vertical asymptote, x equals. Horizontal asymptote, y equals. So, vertical asymptote. What'd you get for the vertical asymptote, Rachel? One. Hands, have you got that? Yes. Horizontal asymptote, everyone. -2. Okay. So let me zoom out and let's graph those or plot those. Alright, so we got x equals 1. X equals 1 is right there. So we go straight down on x equals 1. And y equals -2. 1, 2. There they are. Now just a couple more tallies just for the sake of the graphing portion. Alright, so x, g of x. Now let's see if you remember how to get the domain. Talk to your neighbor, let them know what is it that we need to do to get the domain on our table, please. Good conversations, very good. All right. Let's see, Saul, what do we do? 2 to the left of what? Of the vertical asymptote. Our vertical asymptote is x equals 1, which is there. We need 2 values to the left and 2 values to the right. So now that you see it, what are those values, Juliana? Mm-hmm. Yes, -1, 0, 1, and of course for 1 we're going to write undefined because that's our asymptote, 2, and 3. So you guys can see it. -1, -2, this is 0, 1, 2, and 3. All right, and then the rest we just get to work. So now let me zoom in. Look up, guys. Now, when we have stuff like this, this is a fraction, and it needs to say a fraction in order to substitute values in there. Which means we're going to have to change this one into a fraction so we can do some computation. So here we go. I'm going to do this. 0.5 is the same as what in fraction form? 1/2. So this is -1/2. That is that, yes. Then I got 1 over parentheses -1 minus 2. All right. So then I'm going to write -1/2 times, and then at the end -2. All right, so let me substitute our first value. What is our first value? -1. So you got 1 over, what is -1 and -1? -2. So what is negative times the negative? Positive. 1 times 1 is 1. 2 times 2 is 4 minus 2. So if Brianna owes me $2, but she only has a quarter, she still owes me, right? How much? 1 what? 75. Yes, that is correct. Let's do the next one. -1/2. 1 over parentheses -1 minus 2. And again, I write the -1/2. 1 over and then minus 2. So let's see. My next value is 0. What is 0 minus 1? -1. Okay, once again, negative times a negative become a positive. All right. What is 1 over 1? 1 times a half is 1/2 minus 2. Once again, Brianna owes me $2, but she only has 50 cents. So, still owes me how much? 150. There you go. All right. Next, we got -1/2. 1 over parentheses -1 minus 2. This is -1/2 parentheses 1 over minus 2. So let's see. My next value is 2. What is 2 minus 1? 1. 1 over 1 times -1/2, it's -1/2 minus 2. So Philip owes me $2, but then he asked me for 50 cents more, so that means he owes me what? -2.5. Yes? And last but not least, -1/2. 1 over parentheses -1 minus 2. Move this up a little bit. So I write the -1/2. So 3. What is 3 minus 1? 2. Negative times a positive is still negative. 1 times 1 is 1. 2 times 2 is 4 minus 2. So that gives me what? -2 and a quarter, or 2.25. So far, so good?
Yes, Mr. Q.
All right. Let me zoom out so we can graph this. Here we go. We are at -1, -1.75. -1, -1, and almost to -2, so about right there. Next, 0, -1.5. 0, -1, and 0.5 is about right there. So let's go from left to right, as close as you can to the asymptotes with arrows. And then the other two. 2, negative 2.5. 2, negative 2.5 is about right there. And 3, negative 2.25. 3, negative 2.25, close to the asymptote. From left to right. Now, I don't know if you noticed, it doesn't look like the one we started with in the warm-up. In the warm-up, the graph is on the top right and the bottom left. Is that correct? But let's see why it did that. First of all, this is a half. Is that correct? What does it do to the function? It compresses it. What does this negative do? Splits it. That's why we ended up with that one over here and over here. Okay? All right, guys, so that's the home play. Same process. 3 steps for tonight. I'll stop right there. We good? Yeah?
Yes, Mr. Q?
All right, enjoy your home play. See you guys tomorrow. Bye.